Welcome again to Math Essential Vector Calculus. Today we are again with the curl, but in cylindrical coordinates. As we have discussed in the last time, we have the curl equal to the cross product between nabla and some vector f. This time we represent f in terms of the cylindrical coordinate, where we have some component in rho direction, some component in phi direction, and finally some component in k direction. And as we remember from last time, first we do the derivative and then we do the cross product. And memory also that we have here 1 over phi, and this is just the scaling factor. As we have learned last time, we need to separate each component. So we'll do first component in the rho direction, component in phi direction, then component in k direction. So starting from the rho component, first we do the derivative of the vector as we have said in the in terms of partial rho. To do so, we need to remember together that we need to take care when we make the derivative of the unit vector that not always it will equal to 0. Of course, in rho and z are lengths, so the derivative will always be 0. But when we go to the phi, not always the component will be 0. Anyway, let's do it together. We will keep the cross product here for a while. Let's divide this one to 3 terms. Let's do this one first. When you make differentiation, this is the multiplication rule. So we take the first one, rho, then we take the derivative of the second one. Then again, we keep the second one and take the derivative of the first one, which is rho hat. If you do so, you will find that from here that partial rho hat by partial rho here, it is here, is equal to 0. So this one will reduce to 0, and you will be left with rho hat multiplied by partial f rho by partial rho. Following the same multiplication rule, we can find the same component in phi. I mean differentiation of the phi component and differentiation of the z component. In both cases, you will find that this component partial rho hat by partial rho equal to 0, and partial also k hat by partial rho equal to 0, and you will be left with the first component here there. So just go in this one. Following that, we just come again with our vector here. This is our equation, and now we apply the cross product. So we get the 3 component which we reached here, we put together and make the summation, and then we put in this equation here. And we just need to remember components which are identical. If you cross row by row, row cross row hat cross product row hat, this just equals 0 because there is no angle between them. But if you cross, let's write it again, rho, phi, and k, need to take care of the direction. If you go from rho to phi, make cross product, you will be left with k. But if you make the opposite, mean you go from phi cross product with rho, you will get minus k. Likewise, if you make rho cross k, you will get the remaining, which is phi. But of course, again, the opposite, you will get minus rho. If you go from k to rho cross product, you will get phi positive. But if you make the opposite, meaning if you go from rho and go to k cross product, you will get minus phi hat. So if we apply this here, rho cross rho, this will result in 0. Rho cross phi, this coming with positive, then you will get positive k. And rho cross k, this going opposite way, then you will get minus phi. And just this one is already 0, and you just move these 2 components here. Now we move to the phi component. We will do the same. We'll divide, first find the derivative. First derivative of the first component, we need to take care, of course, again we'll do the multiplication rule. But the important thing here that this one doesn't go to 0. This one has a value as shown here. And once you do the simplification, you will find that you have 2 terms here. Likewise, when you go to the second component here, you will find that when you differentiate partial rho hat by partial phi, this also has a value. It is not equal to 0, so you will be left with 2 components here. Finally, the third component, this one is simple, it just go to 0. Then you will left with only with 1 component. Then we just gather all of these 3 terms here, gather them and put him inside this equation, and then we apply the cross product. Once you apply the cross product, this phi, these two terms are in phi, this will go to 0, this will go to 0, and you will be left with three components. The first component is rho cross phi, this go opposite direction, then you will get minus k. The second component, you are going from phi to minus rho, minus, it will bring minus k, but you already have a minus, then you will be left with k. And finally you have phi cross k, this is a normal way, then it will produce positive sign, and we are left with rho, then you will get rho here, and you just arrange the remaining terms as shown here. This is the last term, which is in the k direction. Again, we'll do the derivative, and again we just are doing the multiplication rule, and since this is k, as you can see here, derivative with z of all the three rho hat, phi hat, rho hat, phi hat, and k hat will always go to 0. You will find that these three components are going to 0. Then you will be left with the first term only here, which is these three terms. You take them together, make summation of them, and then just we go to our equation again, bring our equation here, apply the cross product. Any term which have k will go to 0, because k cross k is equal to 0. K cross rho, this is going in the, because we have, again, let's remind again before the video ends, we have rho, phi, and k. As long as you are going like this, you have a positive sign. If you have go in the opposite way, meaning you are going phi rho, or phi rho k, or k phi, then you will get a negative sign. So let's do together. K cross rho, this give you a positive phi. Rho, k here cross phi, this will bring you rho, but with negative sign, and just the remaining component will just move here. So let's wrap up what we have learned. We want to calculate the curl nabla cross f in cylindrical coordinates. We have already calculated the terms. When we attempted the rho direction, we left with k and rho components. When we attempted the phi direction, we were left with three components. And when we attempted the z direction or the k direction, we left with two components. If we gathered using color code here, we can rearrange like this, and we have here one little bit different component from the others, called 1 over u multiplied by the derivative of u. If you can find that this will be left, but this is just a simple multiplication rule. If you do, you just the first term multiplied by the derivative of the second term, and second term multiplied by derivative of u du, which is just equal to 1. You multiply then this 1 over u by this bracket, what is in brackets, you will this will be reduced to this term, and which is just similar to what you can find here. So we can simplify this term here by this equation. Finally, actually this equation is a little bit difficult to remember so what we do is just we have a matrix representation here for you to easy memorize this one. So this is to summarize. Here we have learned how to calculate the curl in cylindrical coordinates. We have learned the matrix form, which is easy to memorize, and in the next video we'll deal with the curl in spherical coordinates. Thank you.